Hello everyone, it's actually been some time since I've done a video, and I wanted to do a video for those of you that are taking a statistics class or have taken a statistics class and have ever been in the predicament where you need a specific program, specifically an inverse t or inverse chi-squared program that your calculator by default does not have. Now, if you have a TI-84 or higher, then you do have inverse t, but inverse chi-squared I don't think anyone has. Very often what happens is you can download from tutoring center or somewhere from the school that just has them stored in a calculator or in their computer or whatever, and they just transfer it to your TI-83 plus or higher. And there's a lot of other tests too that I won't be getting into. What I will be getting into is how to program the inverse ones yourself. So the inverse chi-squared is often called critical chi-squared, but I'll show you actually how to program inverse. I'll just call it chi-squared inverse, and also inverse t. And it's not that bad. It's actually pretty cool, and there's a lot of math to talk about. So first off, a little bit of a prelude. I want to just recall how CDFs work, because all calculators, even the TI-83 plus, as low as that, have a CDF for every distribution basically that you'll be using. The big ones are normal distribution, student t distribution, and the chi-square distribution. So let's talk a little bit about the normal distribution. So if you look at the normal distribution, it looks something like this, which are a little more symmetric. Okay, mu is in the middle, and if you have values that you want to find the area under between, let's say from A to B, this is the area we want, right? And the way you do this with your calculator is you just type in normal CDF, from A to B, comma the mean, comma the standard deviation. And it gives you the actual area under the curve, where this is that area, right? Okay. Now, if you want to find the x values that correspond to a given area, that's a little more complicated, and there's actually really no way of doing it unless it is completely to the left or completely to the right. The reason being is because if I were to, let's say, move A and B around, there are different A and B values. Let me just kind of move it like this, for example. This may not be exactly correct, but there are different A and B values that if you move them around, you can actually get the same area if they were in a different location. So imagine this area ends up being the same as the area with the different A and B values shifted back over. That could possibly happen. But if you only have one value, let's say we're looking at B only, and you have the right area, then actually, yeah, you can find B uniquely. And that's because the way the CDF would be set up there is it would be from B to infinity. And in fact, there's only one variable here, not two. So that's basically why this works, opposed to the two bounds, lower and upper bound, it doesn't work. But if you have one, it works. Now, to actually find B, that's a B there. So if you want to find this guy, you would actually use inverse norm, which all calculators have. Well, all TI-83 plus or above have, which is what you'll probably be using if you're in a statistics class. You probably know what I'm talking about. So the way you do this is you type in inverse norm of whatever reason, for whatever reason, the standard in these calculators is the area to the left. So the area to the left, comma the mean, comma the standard deviation, and that'll actually give you this specific value B. Now, there are two areas here. There's the area to the left, which I call A sub L, and the area to the right, A sub R. It actually doesn't matter which one you have because they're complements of each other. The entire area under the curve is 1, right? So what that means is that if whatever AR is, it's 1 minus AL, and vice versa, whatever AL is, it's 1 minus the other area AR. Because those two areas that are separated by B are, of course, they add up to the entire area under the curve, which is 1. And I should mention this is going from negative infinity to infinity. And by the way you usually type in infinity in your calculator is 10 to the 99, which is, long story short, basically the largest value the calculator can kind of comprehend. Well, it's a little bit of a lie, but more or less, that's what's going on. And in fact, you can really type in any super large number, like 99999 a bunch of times, but it depends on what mu and sigma are. So 10 to the 99 is almost a guaranteed, like, substitute for infinity. And then, of course, if you're going from negative infinity to that value, then it would be negative 10 to the 99. Okay, so what we want is to kind of do this, but for chi-squared and for t. Now, the t-distribution and the chi-square distribution look a little different than the normal distribution. So to show you what I mean, the t-distribution will look very much like the normal distribution, but it's actually, I believe it's a little higher or low, I forget exactly which one, but it's not exactly the shape of the normal distribution, but it looks kind of like it. And you have what is called degrees of freedom, or df. And chi-squared also has a degrees of freedom. And as df approaches infinity, it becomes closer to a normal distribution. Anyways, with the t-distribution, you have a mean and you have a standard deviation as well, but we're just going to assume that those are 1 and 0. We're kind of playing the standard here. And in fact, with normal CDF, if the mean is 1 and the standard deviation is 0, then in the calculator you don't even need to type them in. And if you just type in normal CDF from whatever to infinity, that'll give you the area assuming that the mean is 0 or 1. So if you have a mean of 1 and a standard deviation of 0 for normal CDF, you don't even need to type them in the TI-83 plus or above. But for T, we won't even consider mu and sigma. We'll just kind of imagine that it is standard. So it's centered at 0. And in fact, I said this backwards, sorry. Mu is 0, sigma is 1, what I meant to say. So if it's centered at 0 and the standard deviation is 1, that's what we're going to be considering here. Now again, for different degrees of freedom, you'll have a different curve and it'll look a little different. And normally we use this tables, but we're kind of at the point in technology where we're so reliant on these things that we're going to use them instead. But again, by default, the TI-83 plus doesn't have an inverse T. So how do we do it? Well, I'm going to explain. Let's say, and I want to set it up similar to this standard, okay? That way it's consistent with what we're using from inverse norm. So I want to be given an area to the left. So the area to the left is going to be our input. And it doesn't matter where the x value we're trying to find, or t value, I guess we can call it, we're trying to find. In fact, I'm going to call it c. So c could be anywhere. I wrote it to the left of 0, but it doesn't really matter. It could be to the right of 0. It doesn't matter. And let's say we're given the area to the left. Okay, I'll just call it a. The other area is 1 minus a. Okay, doesn't actually matter, but I'll kind of use that in the programming, so you'll see that. So what we kind of want to solve is the following. So this is given, okay, in the problem, and this is our unknown in the problem. So the question is, can we find c such that this is true? And really what we're doing is we're setting up this following equation. We want to solve the following. We want to solve TCDF from negative infinity, which again is negative 10 to the 99, to c, comma, whatever the degrees of freedom are, which I'll call d actually, to be equal to a. That's what we want. Okay. So there actually, believe it or not, is a solving program already in the calculator. And with when creating programs, you can actually display the result of solving. And here's how the solve function works in the calculator. When you go to solve, which is math, click on math, and I'll actually show this in a bit. Click on math, you select solve, which is like one of the last, if not the last option. Once you go there, you'll be treated with 0 equals blank, 0 equals something. So basically 0 is isolated in that equation. If I wanted to isolate 0 in this equation, all we need to do is subtract a over to the left side. So that means this turns into that minus a is equal to 0. So all I did is subtract a to the left. Okay, so this is our kind of non-zero side of the equation. That's what we're going to put here. So 0 is equal to blank. We want to plug that in for here. And also, we want to use the variable c. Well, this is what I'm trying to find here. So this is our want to find. I don't know if we've heard of that math acronym before, but that's our want to find. That is a legitimate thing, by the way. WTS is want to show, WTF is want to find, in the context of math, of course. So what I'm going to do is I'm going to set up solving for this in terms of that variable c, and it will display that result. So what we need is we need an input for a, input for the given area, okay? So the user will input a, all right? And then in the background, we're going to set a few things. We're also actually going to input the degrees of freedom. So input degrees of freedom, and we'll call that D. So input, in fact, let me say input the area to the left, or should we call it left area or area left? I guess we'll call it left area. So input left area, and then we'll call that value A. So I'll show how to do this in a moment when I show you the calculator. So we're going to select input. We're going to write left area so it knows, so the user knows that's what we're trying to type in. So that number the calculator will store as what we're calling A, and then input degrees of freedom, and the calculator will input that as D in the background. So the user won't see this, but in the programming we'll write that. And then we're just going to display the following. We're going to display a solving of TI-CDF from negative infinity to C comma D minus A comma C. So this is saying solving for that equals 0 with respect to C. So solve for C in that equation. And that's basically it. Now this is for TI-CDF, and if we wanted to create a chi-squared inverse, then it would be with chi-squared CDF instead of TI-CDF. And that's, I forgot CDF somewhere, sorry. Okay, sorry about that. TI-CDF or chi-squared CDF. Okay. And in fact, this is kind of how, well, I'm not really sure because I don't know the exact programming, but I'm sure this is more or less exactly how the inverse norm program is programmed into the calculator. Now, I have said before that some schools, or depending what class you take and so on, I've taught at a few schools where they have a tutoring center that students go to for the class of statistics, and they offer that program that has all these things: goodness of fit test, critical chi-squared, which is inverse chi-squared, inverse T, if your calculator doesn't have it already, and even a few other things actually. But I've actually looked into those programs and compared them to this program I'm about to show you. Well, I mean, I'm showing it here, but I'm going to show you how it is inputted on the calculator. Anyways, let's see that right now. Okay, the first thing I wanted to show is when you press programs, it will display programs you have, if any, and you can execute them, you can edit them, which is editing the coding, or you can create a new one. Now I wanted to show first I have these three here. This second one is one of the programs I was talking about that the one of the schools I teach at offers students that are in the statistics program. And when you click on this, it gives you a menu for a bunch of other programs within this program. And critical chi-squared is the one I want to talk about. Critical T is similar. And you'll see the program we have for critical chi-squared can be copied over for critical T or inverse T. It's going to be basically the same thing, just with a T-squared or TI-CDF instead of chi-squared CDF. Okay. So when you click on it, it asks you for degrees of freedom. So let's just say it's 20. Okay, and let's say the right tail is 0.6. Notice it asks for the right tail, not the left area. So we want to input the left area to be consistent with what inverse norm asks us to input in the calculator. That way it's not too confusing. But right, so let's just say it's 0.6. So the left area, notice, will be 0.4. Now it's taking some time loading here on the top right. You can see that hopefully. And it will display a value of 17.808. Perfect. Okay. So we're going to go to create a program right now, but what I want to show first is solver. I was talking about solving earlier in the calculator. So if you scroll all the way down, I'm going to scroll up to loop back around. You see the solver right here. It's a last option, in fact. And when you click on this, this x value it's displaying is just the value it last displayed for chi-squared inverse, so don't worry about that. The equation I have up on top is just some polynomial equal to 0. Notice when you go up there and you type in the equation, it says equation solver, equation 0 equals, and you just type in whatever expression you want, and it'll solve that for x. So anyways, once you edit that, you can't edit the equals 0 part. That part's fixed in the programming of the calculator. But the expression that we want to be equal to 0 that we want to solve, you can, of course, edit that. Then once you press enter, it'll ask you for a guess. This is the part I forgot to mention when I was writing out the notes earlier. But let's say we put 6 as an example. Now, if you press enter, it doesn't do anything. But if you press alpha enter, notice that's solve on the bottom right. So when you click alpha enter, it'll think for a bit, and then it'll say what the closest answer is. The closest solution is to that equation, closest to our guess. So we'll in fact actually be using that. That's one part I forgot to mention with solver in the notes, like I said. We'll be using that in our programming. And as it turns out, there's only one solution. There's only one x value that will work for chi-squared or TCDF. And our guess will just be 0, just to keep things simple. But it can be whatever number you want it to be. And notice this is in the bound negative 10 to the 99, comma 10 to the 99. It displays it negative E99, negative 1 E99, but that's this right here, second comma. That's just the calculator's notation for 10 to the. There's actually a few ways to input that. Let me just show real quick by exiting this. So if you press second 99, that's 1 times 10 to the 99. That's just the calculator's way of displaying that. If you do 10 to the 99, it'll display the same thing. So it has a few ways of showing that. In fact, second log is also 10 to the, so that also displays the same thing. So you have 3 ways for whatever reason to display that in the calculator. Notice the way it wrote the bounds with the interval that we want to display our answer from that guess basically, is with braces. So they're not parentheses here, they're braces. Now these braces are right here. They're second parentheses. So just kind of keep that in mind. Okay, now finally, let's get into the programming. So let me exit this, clear everything, press program. We're going to create a new program. We're going to call it inverse chi-squared. Okay, so, right. Getting used to the layout here. I and V for inverse, and then chi is CH, I, and then let's just do SQ for square. Whoops. Yeah, inverse chi-squared. And right there, we've actually reached the maximum amount of characters we can put for a title. So that's good. There we go. Press enter. And now we'll actually get into the programming. So when you press program again, you'll have a few different options. There's control, IO, and execute. IO, of course, stands for input outputs. So we're going to use actually input and display. And that's basically it. Input is going to display, well, input is going to input a user's value given a specific prompt. And the calculator in the programming in the background, which the user, of course, will not see, we will label that value by some letter for some variable. So, and display will just display the result of some solving of some equation. So that's kind of all that is. So we're going to input 2 things. We're going to input the area to the left. So I'm going to second alpha to lock the green. All the characters are green. So let's do left area. So there we go. That's left, and then space is right here. Area. And then, oh, I forgot to put quotations. We want the prompt to be in quotations always. So quotation, oh, I'm going to do, it's fine. Okay. What I just did, by the way, was second delete to insert. That way you don't have to retype everything. So it's if you didn't know that, that's something that comes in handy a lot, actually. Then let's do, how about colon space and then end the prompt. Now after the prompt, that the user will input some number. So we'll write comma whatever we want. Let me leave the alpha, sorry. Right, there we go. So comma whatever we want to call that number the input. So I'm just going to call it A, of course. And now we want another input, and our next input will be the program IO input degrees of freedom. So let's again do alpha lock quote. I'll just write DF for short. And instead of writing a colon, we'll actually write equals, which is second math, which is test, and then we can select the equals character right there, and then we'll end the quotes. Comma, we'll call this input D. So whatever number the user input for degrees of freedom, the calculator and the programming in the background, which the user does not see, of course, is labeled as D. And finally, we will display the following. So program display and we will display the solving of that equation with a guess within those bounds. So if we press math and go to solver, it looks different. It says solve. That's fine. So we want to solve that equation, which was, well, let's see. Second distribution will take you to all of your CDFs, PDFs, and inverses if you have any. So we're going to solve chi-squared from, remember, the area to the left, we want negative infinity to that value, which I called C in the note. So we'll just stick with that. So negative infinity, I'll do negative 10 to the 99, okay, comma C, comma the degrees of freedom. The degrees of freedom are what we call D. And I'm going to close the chi-squared CDF. And now in solve still, I need to emphasize the, actually in solve still, I'm still in the first, I was going to put comma for the emphasis of the variable we want to solve for, but in fact, the equation isn't complete yet. Because remember, we want this to be equal to the area to the left, which we call a capital A here. So I'm going to write minus A, and I wrote this in the notes, so I think this is pretty obvious. Because we're solving 0 is equal to chi-squared of this thing minus that area. So we're finding a value C that will give us that inputted area. That's the idea. Comma C, so that's telling the calculator to solve specifically for C. And now we need a few more things. We need our guess, which will be 0, and then comma the last entry for solve will be the bounds, which remember is in braces, and we have negative 10 to the 99, comma 10 to the 99. So we're kind of saying that it can display any answer with that initial guess of 0 that's from negative infinity to infinity. If you're familiar with Newton's method for solving for roots of equations, it's kind of doing that. So you can create any bounds you want depending on what you're doing in general, but for this, we're obviously going to use negative infinity to infinity. But yeah, anyways. We could close braces and close parentheses, but closing things doesn't really matter if you're at the very end of it. So we're done. Let's press second and quit, and let's see if this works. So now I'm going to press program, and now I'm going to execute this program we just created, inverse chi-squared, and it will ask us for the left area, which is 0.4. Remember, we inputted 0.6 as the right area, so hopefully we get that 17.808 number. Degrees of freedom was 20. And then it takes a little bit of time to display, like it's loading still, probably about the same time, in fact. So the programming is actually maybe pretty similar to what we just went through. And yeah, 17.808, fantastic. And there it is. And by the way, just so we understand what's going on here, if we were to calculate chi-squared from negative infinity to infinity, negative infinity to the value we just found, the 17.808 number. Really, it's 809 if you round, but let's just do 8088, so that's maybe it'll be more accurate. Comma the degrees of freedom. This should give us the left area of 0.4, and it does. If you wanted to do the same thing for inverse t, you would just create a new program for inverse t, and notice that in the programming, I mean, it's all going to look the same. The only real difference is this is going to be with t. So in fact, if I were to just change this to TI-CDF, that's really it. Yeah, so I don't want to bore you by going through that again. I actually need to do that because I initially had, before making this video, an inverse chi-squared and inverse t program that I created, and I deleted them so I can start fresh and show you. So I'm going to have to do it anyways. But right, it's literally the same thing, just with T-CDF instead of chi-squared CDF. So that's pretty cool. That's all I wanted to show you. So hopefully you enjoyed. Hopefully some of you found this helpful. And I think it's great because you don't have to rely on a program already being available. You can do the programming yourself. It's not that bad. You can literally just copy this, and it's pretty interesting. I have a few programs that I'd like to show in maybe a separate video. Some of it I actually even use ChatGPT to help me code. I try to be independent in the sense that I didn't want to have it do all the work for me, so I kind of asked it questions to assist me so I understood what was going on. And those were more complicated programs involving for loops and all this. And I'll actually show those maybe in future videos. Maybe comment below if you want to see something specific, and I'll consider doing a video on that. And hopefully you guys found this useful, and if so, you can like the video, please, and if you're not subscribed, please do so, and appreciate the watch. Take care, and I'll see you in the next video.